discussing about settlement analysis of shallow foundation, right? And in respect of that, we have seen the codal provisions of IS 8009, and in from that we have understood how to calculate the immediate settlement value and how to correct the immediate settlement value after calculation to take care the effect of depth of foundation and rigidity of foundation. Up to this point, do you have any understanding problem? If you have, then you please tell me. Otherwise, we will go to the next part of the discussion. Do you have any doubt? Do you have any question?
No, sir.
Okay. So let's see. Let's discuss the other part. See, now today, today's discussion, what we will do, we will concentrate on two things which are not directly given in your syllabus, but you must have understanding about that. I will tell what is that. But if you do not have the understanding about those things, then in many competitive exams you will face problem, as well as understanding settlement analysis of shallow foundation also you will face some problem. So today we will be focusing or concentrating our discussion mostly on in situ test. In situ test means on the site, means you take your instrument to the site, and from there you collect the soil sample, and directly you get the soil property from some test. Okay, so particularly we will focus on two tests which are very important, and sorry, and in your different kinds of competitive exams also, questions are repeatedly asked from those two tests. One of the test is called standard penetration test. Standard penetration test, the short form of that is SPT, and the second one is plate load test. Plate load test, that is called PLT. If you remember, while discussing about bearing capacity equation in IS 6403, in that, if you remember, from Indian Standard Code 6403, depending on the n value, you could comment on the type of the soil, that is whether it is loosely compacted, dense, or very loosely compacted, and you could get the phi value of the soil, that is the angle of internal resistance of the soil, from the n value. I have shown you a chart, if you remember, from IS 6403, and that n value actually comes from this standard penetration test. So you must have understanding about standard penetration test, that is called SPT, and the second one is the PLT, that is the plate load test. This plate load test is, in many cases, it is being used for finding out the settlement of soil. The settlement, whatever you are calculating now using those formula, that is immediate settlement calculation formula, those kind of that kind of immediate settlement can be calculated using the test procedure, and that test procedure is called PLT, that is plate load test. So today's discussion will mostly concentrate on that, and we will try to link up those two tests with the Indian Standard Code, that what Indian Standard Code is saying related to that. But before that, let's have that understanding about the two tests. Okay, so you see this was previously in your syllabus, but I have prepared slides for this. So if you can see that basically site investigation and soil exploration, this is a very important chapter you should understand in soil mechanics, but I cannot get into too much detail about that. We will mostly get into the details of SPT and PLT. But before that, let's have some brief overview about what is actually site investigation and soil exploration. So basically, site investigation means you go to a site and investigate the site, and you check for different kinds of properties of the site, that is what is the physical property at the site, including the groundwater table, its fluctuations, etc. And then from the site you collect the soil sample and you bring it to the laboratory and test either, or you test directly the soil using some test the soil directly at the site using some test procedure, and those kind of test procedures are basically these SPT, PLT. Then there is another one test called static cone penetration test, that is called SCPT, then dynamic cone penetration test, that is called DCPT, and then you have vane shear test, also a field vane shear test basically. Okay, so these kind of tests you need to carry out to test the to test or investigate the soil at in situ. In situ means you are doing the testing at the site. Okay, so if you see the steps for soil exploration, so I'll be going little fast for this part of the thing. I'll mostly concentrate on SPT and PLT, but this part of the thing you should understand, because other than that you will not be able to get the view about PLT and SPT. I'll share these slides with you so you can have a look at this afterwards. Okay, so steps involved in soil exploration, if you see, what you'll have to do, you'll have to first plan for the soil exploration program. Then what you'll have to do, you'll have to collect the soil sample. Now the soil sample, this is very important term, two terms you should understand very clearly. One is called the disturbed soil sample and other one is called undisturbed soil sample. So when you collect the soil sample, depending on the collection procedure or depending on the sampler you will be using, sampler means the mechanism through which you will be collecting your soil sample from the ground, those are called samplers. And those samplers, depending on the characteristics of samplers, your collected soil sample can be disturbed or undisturbed. Now what is disturbed soil sample, what is undisturbed soil sample, I will discuss briefly just after a few minutes. Okay, and then you see, after you collect the soil sample, either it is disturbed or undisturbed, then what you will have to do, you will have to conduct the necessary in situ test for obtaining strength and compressibility characteristics of the soil. So strength characteristics means, you must understand here, strength characteristics means the properties of the soil through which you should be able to find out the strength of the soil, that is the shear strength of the soil, that is C and phi, cohesion and angle of internal friction. And the other one is the compressibility characteristics. Compressibility characteristics means how much the settlement of the soil will happen because of some load, because under the sustained load by the soil. Okay, so while doing this compressibility characteristic testing or checking, you must understand you will have to go for tests like consolidation test and this calculation of immediate settlement, something like that. Then you should understand what is the groundwater condition. You know what is the importance of groundwater condition, because you have seen that depending on the presence of groundwater, your bearing capacity of soil changes, as well as depending on the groundwater presence, your saturation level of the soil will also change, right? Then you collect the soil sample and do some laboratory testing and of the soil sample as well as water sample. Then you prepare the drawing, charts, bore logs, etc., and then you analyze the collected data, you analyze, and then you prepare a soil report. Okay, so this is actually the complete step involved in a soil exploration process. So you must understand this process very clearly. Okay, now the next thing is the way I just now few minutes back I have told you that that disturbed and undisturbed soil samples. So while collecting the soil sample, before collection of the soil sample, what you will have to do, you will have to do some boring in the soil. Boring means you will have to dig the soil, and from the place where you want to construct your foundation, from that level you should collect your soil sample. So for that matter, what you will have to do, you will have to first do some boring. So what is actually boring? Boring means digging some hole inside the soil for collection of the soil sample. Okay, so basically there are four methods of boring generally used for any kind of soil exploration method. The first one is very simple, that is called auger boring. And you must have seen auger in our laboratory also, when you do your kind of test like your bulk density test of soil, you may have to go to the site and use an auger to collect the soil sample. Then next one is your wash boring, then percussion boring and rotary boring. So every type of boring is specific to specific kind of soil. Okay. So first thing you should understand this auger boring. I am not getting into detail of it. You please go through these slides very carefully afterwards. Okay. So you see, in case of auger boring, if you see, this is a typical kind of auger. If you see, this is called auger. Okay. So auger can be of two types. One is called post hole auger, the other one is called helical auger. These are important terms. Okay. So post hole auger means you just press this auger inside the soil and just rotate it, and what will happen when you will be bringing it out, some soil will be also getting inside this auger and you can bring it up. Okay. However, in case of helical auger, you see, it is just the helical portion of the auger, and if you drive it inside the soil, you cannot be able to bring out the soil sample along with the auger. Okay. So this is the typical difference between your post hole auger and helical auger. Okay. So this auger boring is generally carried out for basically shallow kind of foundation, and in this case of auger boring, you can very easily use in case of soft soil, or in case of, let's say, sandy kind of soil, you can very easily use it. Okay. Or you can use it such for soft to stiff cohesive soil. For this kind of soil, when you want to explore the soil up to particular depth, that is not too much. Okay. So in case of shallow foundation construction, you may use this kind of process of auger boring. Okay. Now next is wash boring. See, this wash boring technique you must have seen. Wash boring is nothing but the process or technique you have seen in case of installing a tube well, or installing any kind of deep tube well or something like that. Okay. So in case of wash boring method, what is being done, some casing pipe is being used along with some chopping bit. Okay, at the end, and the soil is being basically made something like soft using passing of water. And when you pass the water, you just pass with the water with some kind of bentonite slurry. So if you have seen that in our general usage, when tube wells are installed, you must have noticed that some amount of cow dung is mixed with the water. So those kind of cow dung will be just acting as slurry or bentonite slurry, and it will cover up the hole. So that there will not be any fall of the soil inside the borehole. Okay. So this kind of method is called wash boring. And after that, if you see, there is another one method which is called percussion boring, and this percussion boring you will be using in case sorry, in case where you have some kind of rocky strata. Okay. So this method of percussion boring consists of breaking up of the formation by repeated blows from a bit or a chisel. So generally, what is being done in case of percussion boring, you basically just insert some chisel inside the soil and just drop and just drive that chisel with some hammer, and you construct a borehole. Generally in case of this kind of percussion boring, unlike the wash boring, it is not being a wet kind of boring. That means in this case, boreholes are generally kept dry, except you can use a very less amount of water to make a slurry of the pulverized material. So what is the pulverized material? Pulverized material means after chiseling, what will happen? The rocky layer of soil, it will be just getting like dust. So you use very less amount of water inside that to make it a slurry, and that slurry can be bailed out. Bailed out means that can be taken out using some kind of arrangement of a bailer or kind of a sand pump. Okay, so this kind of percussion boring, you must understand at this stage that this kind of percussion boring you will be only using in case of rocky kind of stratum. Okay, and the last important method of boring is called rotary boring. Okay, so this rotary boring is suitable for soil which is highly resistant to augering or washboring. So that means if you cannot collect your soil sample, or if you cannot do a borehole using your auger, that means either your post hole auger or helical auger, or you are not able to do it using your wash boring technique, in such case you can use a better technique than those two, that is called rotary boring. Okay, so this rotary boring technique basically are of two type: mud rotary drilling and simplified mud boring technique. In both the cases, if you see this, it is similar, kind of similar technique to your wash boring technique only, but with some different arrangement being made. Okay, so in this rotary boring technique, the drilling, the bit, whatever you will be attached, bit means drilling bit. So you see, this is your drilling bit. So at the end of the arrangement, which is actually cutting the soil and getting inside, that is called actually bit. Okay, so in case of rotary boring, if you notice, the rotary bit or this drilling bit will be called as core barrels. Okay, so in case of rotary boring, the drilling bit will be called as core barrels. In many competitive exams you will notice that core barrels, where the core barrels are used. Core barrels are nothing but the drilling bit in case of rotary boring technique. So these core barrels are fitted with diamond bits. So basically diamond is a very hard material, and the diamond can cut anything very easily. So in case of rock cutting, you can use this rotary drilling technique, which is called core drilling. Okay, so this core drilling is basically your rotary boring technique, and in this rotary boring, the bits whatever you will be using, those will be called as core barrels. So you must understand this. For typical site investigation or soil exploration, what are the methods generally will be used? Okay, so what are the methods I have told you? There are 4 methods you should be particularly using. First one is auger boring, second one is wash boring, third one is percussion boring, and fourth one is rotary drilling. Okay, so is there any doubt up to this? So after that, you see, I have just at the beginning of the lecture I told you that whenever you are doing any soil testing, at that time what you have to do, you'll have to collect your soil sample. Okay, and the soil samples may be of two types. One is called sorry, one is called disturbed soil sample, and the other one is called undisturbed soil sample. Okay, so if you use your if you see what is a disturbed soil sample and what is undisturbed soil sample, just very basic definition, you see, very simple. So a disturbed soil sample is a sample where the natural structure of the soil gets modified during the sampling operation. So what is sampling operation? Sampling operation is nothing but the collection of the soil sample using a soil sampler. Now what is a soil sampler? soil sampler is nothing but a mechanism through which you should be able to go up to a particular position inside a borehole, and then from there you should be able to collect the soil sample. Okay. So if your soil sampler is such, the mechanism or structure of a soil sampler will define whether the soil sample you will be collecting will be a disturbed soil sample or undisturbed soil sample. So when the original structure or the natural soil structure of the soil you are collecting through a soil sampler gets disturbed, that will be called as a disturbed soil sample. And what is undisturbed soil sample? The undisturbed soil sample will be a sample which is basically the soil structure will be holding or will be preserving its original structure. Okay. And the material properties will not undergo any alterations or modifications. So inside the soil, after collection of the soil, if you test the soil, the material properties of the soil will remain unchanged. Okay. So it is very, very difficult to obtain an undisturbed soil sample. So practically it is impossible to obtain. However, we can go for near approximation of collecting undisturbed soil sample. And if we can design a soil sampler in such a way which will be able to collect the soil sample using without disturbing its original structure, that will be called as undisturbed soil sample. Okay. So the material subjected to, obviously the materials will be subjected to very small disturbances. So if we can collect the sample using very small disturbances of the material, and we can test the sample collected for shear strength and consolidation, such kind of soil sample will be called as undisturbed soil sample. Okay. Now disturbed soil sample again can be classified under two categories. Okay. One is called representative soil sample, other one is called non-representative soil sample. So what is representative? Representative means with suitable precautions the natural moisture content. That means if you collect the disturbed soil sample, from the disturbed soil sample you may be able to know the moisture content of the soil, mineral content of the soil, or you can test for identification of the soil. That means you may be able to use that soil sample for your liquid limit testing, for your plastic limit testing, or for the sieve analysis. That means identification of the soil parameters, identification of the soil. For that you should be able to use if you collect the soil sample as disturbed soil sample. But a disturbed soil sample, when it is representative one, then only you will be able to do it. That means a representative soil sample will be holding its moisture content to a perfect level. On the other hand, a non-representative soil sample, is the one where the soil from other layer gets mixed up. So one layer of soil will be getting mixed up with the other layer of the soil, the mineral constitutions, the amount of what is called moisture content will be getting disturbed, and in such case the soil sample will be called as non-representative. So you must understand here that in case of disturbed soil sample, if you collect disturbed soil sample, using the disturbed soil sample you should be able to find out the moisture content of the soil, mineral content of the soil. Even you can use it for identification property of the soil if it is representative one. If it is non-representative one, then you should not be able to find out those properties also. However, you must understand that from the disturbed soil sample, that is whether it may be representative or non-representative. Just a minute. Okay. So you see what I was telling, undisturbed soil sample. So you see if you want to test the shear strength properties of soil or consolidation characteristics of soil, then you cannot use disturbed soil sample. You must understand. So you must have to have undisturbed soil sample for shear strength characteristics testing and consolidation characteristics testing. Only undisturbed soil sample can be used for soil identification and for moisture content determination, and that too, for disturbed soil sample it must be representative one. Is it clear?
Yes, sir.
Yes,
Okay.
sir.
So can anyone
Sir,
tell, can anyone explain me that till now whatever I have explained? Bolo. Any
sir,
question?
how can we identify that sample we take out is disturbed or representative
Yes, I'll
and
come. I'll
undisturbed?
come to that in the next slide. Okay, I'll come to that in the next slide. Next part of the discussion will be on that. Okay, how to determine whether it is disturbed sample or undisturbed soil sample. See, whether the soil sample collected will be a disturbed one or undisturbed one, that will depend on the soil sampler. Sampler means, sampler is a mechanism. I'll show you what is a soil sampler, and depending on the thickness of the sampler and the material of the sampler, the inner and outer diameter of the sampler, a soil sample will be defined as disturbed soil sample or undisturbed soil sample. Okay, let us see what is what how do you collect undisturbed soil sample. So let's go to the next slide. See, this is what is actually your question. This will answer your question. Okay, so see, requirement of sampling tool or samplers. So this is, see, this you have seen also. See, you have, when you have done your no, you have not done, right? Or this practical in this fifth semester laboratory, soil mechanics laboratory, whatever the online laboratory classes is happening, in that you have seen that core cutter test. Core cutter test you have studied
Yes, sir.
for bulk density identification. Okay, so see, this typical a core cutter, see, is a to core cutter, if you have observed, a core cutter is typically a soil sampler, kind of a soil sampler. So you see, a soil sampler will look something like this. So soil sampler is nothing but something like this. So you see, there will be a sample tube. You see, there is a sample tube. So this portion, whatever the arrow I am showing, this and this is a sample tube, and you see, to that sample tube there will be a cutting shoe attached to it, cutting shoe. Okay, because when you will be collecting the soil sample, obviously it should have some cutting edge, otherwise it will not be able to bring the soil sample inside the sampler. Okay, so this sample tube, see, this is a sample tube and cutting shoe, but along with this there will be some kind of valve arrangement. So arrangement of valves are also there inside a sampler. Okay, so the opening of valve and closing of valve will be able to bring or fetch the soil inside the soil sampler, because you see, if it is completely open like this, then what will happen after you cut it? Then what will happen? If it is not very stiff kind of soil, it will just come down while you will be bringing it up. But no, that will not be the case, because there will be some kind of valve, arrangement of valves, okay, inside the soil sampler. Through that, through the arrangement of those valves and through the mechanism of those valves, okay, it will not come out. Okay, now we will not go into the valve arrangement, but the question I think Vivek was asking, or Vivek or Sumit was asking, I think Sumit Sagar, that how do you sample it? Okay, how do you sample? How do you define that whether it is disturbed sample or undisturbed soil sample? It will depend on just two things. One is this sample tube and one is this cutting edge. Very clearly understand. See, this sample tube will have some thickness. So the outer diameter of the sample tube, you see, dt, and the inner diameter of the sample tube is ds. That means the thickness of this sample tube is dt minus ds. Is it clear? Now you see, there is a cutting edge. Okay, so if you just draw a parallel line from the inside cutting edge and the outside cutting edge, just drop a parallel line from this, and you take the cutting edge inside diameter. So cutting edge inside diameter is dc and cutting edge outer diameter is dw. Okay, and according to this, if you observe Indian Standard Code 1892, it has defined the collected sample whether it will be disturbed or undisturbed based on these four parameters, that is dt, ds, dc, dw. Okay, so you see, if your inside clearance, what is inside clearance? Very carefully you observe. So inside clearance is nothing but the sample tube, the inside of the sample tube, you must observe here. So see, the sample tube diameter, inside sample tube diameter, this is ds. You see, the inside sample tube, inside cutting edge diameter is dc. Okay, so ds minus dc by dc, if you see, this is called inside clearance. Okay, so if inside clearance between 1% and 3% of the internal diameter of the sample tube. Okay, so if your inside clearance of the soil sampler remains between 1 to 3%, the collected soil sample will be your undisturbed soil sample. But if it is more than the inside clearance is more than 3%, then you may expect that your collected soil sample will not be undisturbed soil sample. Okay. Now the next thing is outside clearance. This is also important. So you must check for inside clearance. You must check for outside clearance also. So what is outside clearance? See, outside, when you just look at the difference between inside clearance and outside clearance. You see, the sample tube inside diameter is more than the cutting shoe diameter. You see, inside cutting shoe diameter. So that is why ds minus dc by dc you are doing. On the other hand, if you observe, when you are calculating your outside clearance, you see, the sample tube outside diameter is less than the outside diameter of the cutting shoe. So outside diameter of the cutting shoe, that is the cutting edge, minus the inside diameter of the sample tube divided by the inside diameter of the sample tube. So if you find out a percentage of this, then the outside clearance should not be much greater than the inside clearance. That means whatever value of outside clearance you will be getting, whatever value of the inside clearance you will be getting, your outside clearance should not be much greater than that of the inside clearance. That means, what does it mean? It means that if your inside clearance remains within, let's say, 1.5%, your outside clearance should not go up to 3%. It may be 1.6%, 1.7%. Okay. So the inside clearance and outside clearance must be related. So if you are getting inside clearance for a soil sampler, let's say 1%, your outside clearance should be also nearing to 1%. It should not be 3%, 4%, something like that. Okay. So if you are having your inside clearance and outside clearance of the soil sampler like this, then you may expect that the sample you will be collecting, that will be undisturbed soil sample. Now the next is another one thing also Indian Standard Code says you should check for your soil sampler, that is called area ratio. Okay. So what is area ratio? See, area ratio you should observe here. Area ratio is the ratio, the square of the ratio. That means area. That is, what is area of the soil cutting edge? Inside area of the cutting edge, outside area of the cutting edge. So outside area of the cutting edge is how much? Pi by 4 dw square. Right? Sorry, pi d square by 4. Right, correct. Pi by 4 dw square. And what will be the inside edge or inside diameter, inside area of the cutting edge? Inside area of the cutting edge will be pi by 4. So outside edge is dw, outside cutting edge diameter is dw. So what will be the area of this cutting shoe? Outside area, it will be pi by 4 dw square. Inside area, inside diameter is dc, so inside area will be pi by 4 dc square. So if you take the ratio of this area of this cutting shoe, please understand inside clearance and outside clearance are related to sample tube and cutting shoe. Both the terms are coming over here. Whereas in case of area ratio, you must see that it is only dependent on your cutting shoe diameter. Okay. So the area of the cutting shoe, outside area of the cutting shoe minus inside area of the cutting shoe divided by this inside area of the cutting shoe multiplied by 100. If you find out it in percent, then depending on that you should be able to understand whether the collected sample will be disturbed one or undisturbed one. So your value of this area ratio should not be greater than 20% for stiff formation. You should understand very clearly. So there are differences in values, you see. So if you are collecting a soil sample which is stiff kind of soil, that is stiff clay or something like that, then your area ratio value should not be greater than 20%. Whereas if you are testing it for soft sensitive clays, then the area ratio of 10% or less should be preferred. That means if you are going to test for soft kind of clay, or if you are going to collect the soil sample for, let's say, sensitive clay, or if you are going to collect soil sample, let's say, for sandy loose kind of sandy soil, in such cases your area ratio value should not exceed 10%. Whereas if you are testing it for your if you are testing it for stiff kind of formation where the clay is very stiff, in that case your area ratio value may get you may go up to an area ratio value of 20% for your soil sampler. Okay. So if you understand this part, then you should be very clear about what is soil sampler and how to find out whether your collected soil sample will be disturbed one or undisturbed one. Is it clear? Now you see.
Yes, sir.
Now you see.
सर
Yes. बोलो.
सर इनसाइड क्लियरेंस और आउटसाइड क्लियरेंस का सर मतलब
और एक बार बोलो, समझा नहीं.
सर इनसाइड क्लियरेंस और आउटसाइड क्लियरेंस.
What does it mean?
यस सर.
See, inside clearance, देखो, this is a soil sampler. A typical soil sampler, in whatever form you will see, a typical soil sampler will be having some arrangement something like this. So a soil sampler will be having a sample tube. So you see, this is your sample tube, this one is your sample tube. Okay, and to this sample tube a cutting shoe will be attached, a cutting shoe or cutting edge will be attached. Okay, so inside clearance and outside clearance means, see the sample tube, see when the soil will be getting inside this tube, what is being said, the difference between this inside diameter of the cutting shoe and the sample tube should not be much. Exactly on the same way, the difference of diameter between this outside diameter of the cutting shoe and outside diameter of the sample tube should not be much, and that percentage of change should not be more than 1 to 3%. That is being defined, okay, by the Indian Standard Code. So this is actually your inside clearance and outside clearance. So when you define inside clearance, you see inside clearance means this is your inside diameter of the sample tube, so this is your ds, and this is your inside diameter of the cutting edge, so this is your dc, so ds minus dc by dc. So if you get it and then find out the percentage, then if you are getting the value of this inside clearance between 1 to 3%, then your collected sample you may expect it will be undisturbed soil sample. Is it clear?
यस सर. सर इसमें डिवाइड क्यों कर रहे हैं सर डीसी से?
DC से divide इसलिए करना है because you see you will have to find out a percentage. Okay, so that is being defined by the code. Why it is being divided by DC, please understand. This is also you can very clearly understand. See, if you do not divide it by DC, see, if you do DS minus DC, you will not be able to find out a percentage. So code is defining the value in terms of percentage. Second thing is, if you just take a DS minus DC difference, if you take just a DS minus DC difference, then it is going to give you absolute value of the difference of the diameter. Whereas if you do it DS minus DC divided by DC, then you are getting it in terms of relative term. That means how much DS is more than DC in terms of the difference of the diameter. Because if your DS minus DC is too much, and let's say your this DC is less, if your this DC is less and your this DS is too much, okay, so what will happen in that case? In that case you are going to get a more higher value at the numerator. Whereas you see, it may happen that DS is less and DC is more. So if DC is more, then more means not more than DS, it is value is little bit more. So if DC is more, then DC is more DC will do what? So more DC will reduce this CI value. Okay, so that means you see, when the soil is getting inside this cutting edge, and from this cutting edge it will be getting pumped into this sample tube, at that time the probability of changing its structure and other things will be lesser if this ratio is within 1 to 3%. That is why it is being divided. Okay, so absolute value difference is not going to give you proper indication about this sample collection. That is why it is being divided, and it is also defined in the code, Indian Standard Code IS 1892. So you can just download IS 1892 and you can see detail about this soil sampling process. Okay, so should I proceed?
Yes, sir.
So now you see this sampling tool. Okay, so requirement of soil sampling tool. So you have seen, I have explained you what are the requirement of soil sampling tool. So that is the point. If you someone was asking, I think that is why I will have to take ratio. So you will have to take ratio to control this inside wall friction, because you see from one portion to other portion, when the soil is being pushed, that means from the cutting edge to the soil sampler, when it is being pushed, there should not be too much of wall friction. Okay, so the value difference between this inside and outside diameter of the sample tube and the what is called cutting edge should not be much. Exactly the same way, the difference between outside diameter of the sample tube and outside diameter of the cutting edge should not be much. Otherwise you will have wall friction getting generated, and if the friction is too much, then what will happen? Then the probability of the soil sample being disturbed will be much. Okay, so to avoid the wall friction also, you must provide suitable inside clearance. You should provide a smooth finish to the sample tube, as well as you put some grease, oil, some kind of thing inside the tube. Otherwise while pushing the soil up, it may be getting disturbed. Okay, sorry. Now the second point is non-return value. What is this non-return value? So I have told you that there should be some valve arrangement, because you see, if you do not have valves inside those soil sampler, then what will happen? When you will be pulling it up, all the soil will be getting dropped from the soil sampler. So there must be some valve arrangement. So one valve will be getting opening up, and when you will be pulling it up, the valve will be getting closed, such that all the soil sample will be getting intact within the sample tube, right? So this valve arrangement should be such and should have a large orifice. Orifice means there should be a hole, to allow the air and water to escape quickly. If the air and water is not escaping quickly from that soil sampler, then what will happen? Because of the air pressure or because of the water pressure getting generated inside the soil sample after being getting collected may get disturbed. So that is very important point. Okay. And the third point is also very important. This recovery ratio, you must remember this point very clearly, because many competitive exams ask about this recovery ratio. Okay. So what is recovery ratio? You see, it's very simple to understand. Recovery ratio is nothing but the length of the soil sampler, okay, and the amount of length of soil sample you are collecting. That means, suppose you are driving a soil sampler inside the soil, okay, and after collection of the soil sample, you will notice that some portion of the soil may be getting outside the soil sampler, okay, or it may be exactly equal to the length of the soil sampler, or in some cases you may find that the length of the soil sampler, that means there you may notice some soil portion of some soil is getting bulged out of the what is called the soil sampler. So the recovery ratio, this is very important. So recovery ratio, you see what is recovery ratio? Recovery ratio is nothing but L by H into 100, which is length of the soil sample within the tube. L is the length of the soil sample within the tube. Okay. So the amount of soil sample you have collected, that is the length of the soil sample within the tube, and H is the depth of penetration of the sampling tube. So if you are fully penetrating the depth of the soil sampler inside the soil, that is totally the height of the soil sampler, or if you are penetrating the soil sampler, let's say up to half of the depth or 3/4 of the depth, so the amount of depth you are penetrating inside the soil, that is actually your H. And if you divide the length of the sample collected by the depth of penetration of the soil and take a percentage, then you will get recovery ratio. So this recovery ratio actually finally will define whether you have collected your soil sample as disturbed or undisturbed. So if your recovery ratio remains between 96 to 98% value, in such case you can confidently say that you have collected the soil sample very well and your sample collection is undisturbed soil sample, provided you have met those requirements as I have explained, that is inside clearance should be remain proper, outside clearance should be remain proper, as well as your area ratio of the sampler should be remaining proper. Okay. So if all those three things are remaining proper, if your inside wall friction is less, if there is proper non-return value given, then after that, if you are recovering a soil sample with a length with a percentage of 96 to 98%, then you can confidently say your collected soil sample is undisturbed soil sample. Okay. So obviously, if you can have your recovery ratio as 100%, then you have collected your soil sample to the perfect limit. So it's a very good recovery. If it is less than 100%, then it remains, you can understand it is a compressed soil sample. Okay. However, you may expect, as I have just a few minutes back mentioned, that you may observe some bulging out of the soil sample. That means the length of the soil sample collected may be little bit more than the depth of penetration. In such case, your value will be more than 100%, and this will happen in case of a swelled soil. So if a swelling of the soil happens, okay, so from the sample collected, from the recovery ratio itself, you should be able to comment on whether the soil is getting swelled or not. Okay. So in a swelled soil, you should be able to get such kind of property. So from the recovery ratio, you should be able to tell about the soil characteristics also. You must understand here. Okay. This recovery ratio term is very simple to understand. You must remember this term. Many competitive exams gives you a question from this recovery ratio for 1 marks, 2 marks. Okay. Is it clear? So should I stop here? or should I proceed for the next class? कितने बजे है next class? 1:45.
Yes, sir.
So should I start at 1:45 or what do you tell? Should I continue for another 1 hour? ये लंच वंच करके फिर से करना है, बोलो. So let's have it afterwards, right? Should I stop here now? In the next class we will discuss this penetration test, SPT and PLT. Okay? Is it okay?
Okay, sir.
Yes, sir.
Yes, sir.
Okay. So let me take the attendance and then we'll stop for today's today's at this lecture, and then again we'll meet at 1:45. 1:45, 1:50 will start. Okay. But please join at time. Don't go beyond 1:50. Because I'll start with standard penetration test. Okay. Okay. So you can please leave and have your lunch. Okay. Thank you.
Thank you, sir.
Thank you.
Thank you.